Hey everyone, this is Jason Dinsmore again from OrganicChemistOnCall.com. Lastly, we talked about nucleophiles, and now what I want to do is kind of use that information to kind of go into, let's say, resonance and possibly talk a little bit about electrophiles, but once again, we'll see if we get into it. I think one time I said I was going to talk about it and never did. So the main thrust of this is going to be resonance structures and how to use the existing terminology and visual things we've done thus far. Kind of figure out how we can use that. So let's see, how do I want to start this? So what we're going to do here is let's think about a double bond. And I'm not going to put dots on everything because that's just going to get really confusing, but I'm going to put them in what I think are kind of the most important places that'll kind of give us the information that we need. And what I'll first do here is what we know is that the position here, we know there's going to be two hydrogens there because we need 4 bonds of carbon. I'm just going to draw one of them just for simplicity's sake. But we know positions that are in the allylic hydrogens, or the allylic position, is the carbon that is directly off of the double bond. So if we were talking about this carbon right now, that's considered a vinyl position, or if we had a hydrogen, that's called a vinylic hydrogen. The allylic position is one off of the double bonds. That's either a allylic carbon or an allylic hydrogen. That allylic position, this hydrogen specifically, are acidic. So if we have some sort of base with a minus charge, that base can come in, we can pull those electrons off, and then we can push them down on that atom. And what that'll do is, that'll give us a minus charge there, and then if we keep everything the same, we are going to have an H and B. So we've got a minus charge. So we've talked about this, how we can generate that. We'll go into a little detail down here. What does that look like if we're going to draw that in terms of electrons? So this is kind of just some rehashing. I like to go over this just to kind of refresh, as well as those that might just be jumping on this video. So what we talked about is, in terms of acting as a base, we're going to use the lone pair here that's not part of a bond. That's going to come in. That's going to grab that hydrogen. And what that means is then we're going to have to push both of those electrons down there. So to keep the colors the same so we can see, what does that look like when we follow that through? So we'll do the base first. So the base is going to use its electrons, it's going to act as a nucleophile, it's going to donate its electrons to grab onto that hydrogen, and in that case we're going to use both of those electrons to form a bond. Now we know hydrogen can only have one bond to it, so that means those electrons can't be associated with that hydrogen at all. We only want one electron around hydrogen. We've got it right there. So that means that those have to fall onto that carbon. When they fall down onto that carbon, we'll keep these here. We know that this carbon, if we look up here, has a total of 4 electrons around it. So when we push those down now, we have an extra one that's 5. So that's going to give us a minus charge right there. All right, so that's how we generate that. Now what we want to look at is, how can we use this to generate our resonance structures? What we've typically seen with resonance structures is not the way that I've drawn it down here, but this one, where we say, okay, we can take this minus charge, we can dump that down there, we can push that over there, and what that would do is give us a new structure, and I'll use the colors. So we've got red, a negative charge there, we're going to push, whoops, got too many bonds there, that's going to push down there, and then that's going to push that black bond down to the end, which is, I did this wrong again, not even paying attention here, sorry guys. So that's going to give us our red bond there, and then that's going to give us our black bond there. So that's a resonance structure where we're taking, resonance means you're taking a set of electrons, whether it's neutral, no charge on the molecule, or it's charged, and you're kind of moving those around. So what we've done is we've taken this negative charge, taken it from this secondary carbon here, and we've pushed it all the way out on the primary. So what does that look like in terms of our electrons? So let's take this structure. So why does it work this way? So if we look at this carbon right here, like we've talked about, I haven't drawn all the bonds, we just kind of have to trust me on this, that this right here has one extra electron because we have no hydrogen on it, so that's going to be negatively charged. So what we're doing here is we're taking these 2 electrons and we're dumping them down there. So what would that look like if we didn't change anything, we left it on there? So that means that we're going to wind up putting those 2 electrons between those 2 bonds. We already have this electron there and that electron there. So what happened in that case? Well, if we look at this, we know that this carbon, whoops, this carbon right here now only has 4 electrons around it. And if those of you that are stumbling upon this video now and haven't looked at the existing ones, go ahead and check them out because I talk about how to count the electrons. This has 4 electrons around it, so it's neutral. What happens here is before we move this, we already knew that this carbon right here, if we look up here as well, is completely neutral. When we dump another electron down there, now what we've essentially done is we have 5 bonds to carbon in there. We can't do that. So something has to give. So the reason that we have these resonance structures is not because, oh, this is a fun thing to do, but electronically it starts to move things around. So in order to do that, what we then have to do is move these out of the way, get one of those electrons where we've got 1 electron on that carbon, 1 electron on that carbon. We're going to dump both of those electrons on the N carbon, which then gives us an electron there, and now those 2 electrons are out on the end. So now our minus is out there. So you can see that once we get beyond the scope of that initial things of looking at electrons, trying to draw them, if I were to draw out all the electrons on here, it would be incredibly confusing. It wouldn't make any sense. So you can see to this point, we're getting to a point where it's going to get really difficult to kind of draw them. So I'm just drawing the key features here. But if you go back, if you haven't looked at them, look at the initial videos on nucleophiles as well as some of the other ones. I'll put a link in there to kind of show you what we're doing. But you can see here, if you kind of think of bonds in terms of electrons, it kind of makes sense in what we're doing. So this just shows you how resonance, if we just look at the top one versus what electronically, what we want to make sure is that we keep the correct number of electrons around each atom.